Okay, airspeed's 5.
Kind of curious to see it if I made a bad decision, what it would do.
From a nav geek perspective, it's friggin' amazing to get behind the scenes for this.
I've never seen anything like it, honestly. It's on a scale that is really, really impressive.
We got unprecedented access to the brand new manufacturing and R&D facility.
We're shaking things, we're baking things, we're taking them to extreme altitudes.
So we can take it to very hot environments, very cold environments, and then we can also shake it at the same time.
It must go through a lot of liquid nitrogen.
This is where you cook it.
This is where we cook our stuff, yeah.
What happens if your airplane gets hit by lightning?
Yeah.
We figured that out down here.
Yeah.
You can end up with something like this.
So we're headed to our reliability lab.
We just try to, it's a room, it's where we try to break things.
It's super nerdy, and we're gonna get really deep diving into the background of what happens at Garmin. That is a nightmare. Buckle up for the next 2 minutes, then we'll slow it down to unpack what I'm about to frenetically throw at you. Is there anything top secret that can't be on camera, or we're good to just be shooting?
We should be good.
You guys put away the flux capacitors? All right, so we are at Garmin today, and we would be crazy not to explore this option for the RB14 panel.
We've got to see some pretty ridiculous behind the scenes things here.
We're going to show you some engineering lab facilities where we test all of our certified and non-certified aviation equipment, where we hit it with a lot of radiation.
We can produce some pretty high levels in here.
So right now, are we getting radiated? Like, what's going on?
Absolutely.
Just had to ask.
Yeah.
Like, it's gonna be like,
As we develop software, we put the latest and greatest builds on this. Latest and greatest often means buggy, so we need to work through all the issues that we've developed.
What you're looking at here is our cockpit for the Bell 525. It's a brand new large helicopter they're just certifying. You're hovering. You're right now, you're 8 feet off the ground. You're holding it pretty stable. Most guys can't do this right off the bat.
we're gonna share how they build, calibrate, and field test this stuff. Okay, airspeed's 5, cross check.
It's gonna save us, right? Oh, look at it do it.
All that technology that goes into all of our aircraft is built right here next door. And it's awesome. We got robots, it's extremely advanced. We just invested $200 million in that facility.
There you go.
Charge check, basically.
What's checking is that you got a complete ground.
Okay.
So that your feet are actually grounded.
You're all grounded, yeah.
All right, then we're gonna go through an air shower. What it's doing is just knocking off any dust or light debris that may be on your body. So we're gonna walk through at a normal walking pace, hands up like you're on a roller coaster.
We'll get back to the factory to see how this stuff is built. But first, they showed us how it's tested, and they take it quite literally to the limit. Here's a quick sample of a bunch of the things we'll be expanding on in this episode. Ready to keep the octopuses?
So this equipment here is a salt fog chamber. We atomize a salt solution into fog.
In a microwave, the food turns around to heat evenly. In this room, that paddle right there spins around and it's cooking our equipment in here.
We're here to do electromagnetic compatibility testing. And you're welcome to step in here if you like, as long as you stay.
Yeah, I was going to follow your lead on that.
Every room in this place is the coolest. Like
They're all different flavors.
We're gonna go look at the HALT chamber. HALT stands for Highly Accelerated Life Test. The purpose of this test is actually to break it. If you don't break it, then you're really not doing the test, right?
So we're putting a load on a servos.
How long has that poor guy been being beat up for?
This one here has been in here for weeks, just sitting here doing this.
Wow.
That is a machine we use for putting watches on and doing water strikes.
Okay, there's a lot to cover, so let's slow it down for a nerdy deep dive.
This is our Anacorte Chamber. Radiation gets absorbed in the walls.
So let's close the door because I want to hear how silent it gets.
It's gonna be quiet.
This is so cool. I wonder if the camera will notice.
That's so weird.
That's neat.
Yeah. We've got a whole GFC 500 set up here. Our HERF and Lightning team kind of sets these tests up to be run as a whole system, but we'll hit this with different EM fields, continuous wave, pulse wave, square wave, and try to see if we can make the equipment upset. If it does, then we fix it and retest it until it passes.
So essentially this is where you try to break it.
This is where we try to break it, yeah. Nick's good at breaking our stuff.
Good job.
But we're gonna hit these servos pretty hard.
So these are Autopilot Servos?
Yeah.
Yeah, so that's basically the Autopilot that we would be putting in.
That's the Autopilot.
And then you got a couple G5s here. My experience with this type of stuff on the walls is for like sound recording to like, and I can tell it's dead silent.
Yeah.
What is the advantage for the type of testing you're doing? Why does it need to be in here?
There's no real requirement that we have to have this anechoic foam on the walls in here to do this test, but we need to be somewhere where people aren't. And so the foam absorbs that RF that re-radiates off of the bundle and keeps us safe on the outside. There are some tests where, like if you're testing an antenna, sometimes it's desirable to not have stuff bouncing off the walls or the ceiling or the floor, and you do those kind of tests in an anechoic chamber too. But for the purposes of what we're doing down here, it's all about keeping us safe outside.
So we'll be videotaping, especially the things with displays, or
to see if they glitch or whatever.
To see if they glitch, right? And so that's why they're all taped up and shielded up, so the cameras themselves don't upset when we're testing them.
So my name is Brian. I manage Team X. We have the software and hardware electrical engineer team sitting up here, so that's this is our area. So this is Justin. Justin is our G3 expert. When people are reaching out to G3 expert to get help, Justin is kind of the person who manages all that.
So a lot of the guys here, are they all pilots pretty much, or like a lot?
Yeah, so on Team X, we really try to find pilots, home builders. So Joey's building a 10, Brad's building a 10, Johnny's flying RV6, Justin and his dad build an RV7, Tony's a pilot, Joe's a pilot, I'm a pilot.
And of course, Team X has an RV7 in the fleet. Dave went for a flight to test out the panel, and I stuck around to cover more of the Team X backstory. It's pretty cool.
So one thing that's really unique about Team X products is that we started out in the experimental and light sport aircraft market, but the quality of our products really spoke for themselves and earned their way into the certified world. So the G5 started out as our backup attitude indicator for the G3X touch system. But we saw that this product we designed was so much more reliable than the mechanical gyros flying around in a lot of older aircraft. At the same time, the FAA was acknowledging that these solid state sensors are much safer to fly with. Their failure mode is not as subtle as the vacuum pump, which slowly, starts to lean and tumble.
But in here we're loading up, G5s, 275s, GI 275s, GSU 25s, different ones. And so then they're hooked up to this piece of equipment that's simulating different airspeeds and altitudes. And then we're doing that at different temperatures. So that's how we set up that calibration matrix. And then we go in and do a cold test, hot test, and final test to validate that, yeah, it's measuring altitudes and airspeeds correctly at all those different temperatures. So like I said, they'll be in this chamber for up to 24 hours. We're a very high mix, low volume, if you will, from the standpoint of, we're not like a cell phone company where you set the line and run for 6 days straight on the same run. A lot of our runs will, be anywhere from, 30 boards to maybe a big run is 900 boards. And that's the most run that we'll do at any time. So for us, it's more about accuracy, quality, and changeover than anything else.
I'm assuming like when you do a run of production, you pull like a couple of samples and you'll test
all of it.
Every single one.
Every single unit.
We test every single one of them, so we don't just pick a couple from a lot and do that. We do every single one of them.
And it's hours upon hours of testing.
For every single one.
So we will break it before you break it, is the goal.
So they get both air data testing and rate table testing. It's interesting that you see that they're on an angle with the rest of the room, and that's because they're lined up with true north, not magnetic north, but true north, so that the sensitivity of these is so high that we're having to take out the Earth's rotation. And then they're also hooked up to liquid nitrogen, as well as have their own internal heaters, so that way we can take them through different temperature profiles while we're calibrating and while testing.
Most of our equipment is calibrated around a maximum of 250 degrees per second.
So I guess that's a good point, that this stuff won't topple like a gyro.
Yeah. You never get our AHRs to tumble, basically.
Tumble. Tumble?
Yeah.
Okay.
It can spin up to 1800 degrees per second. The outer axis can go up to 500 degrees.
So that right there is the whole brain of the AHRs.
This is, I actually designed this one.
You designed it?
I designed this one, yeah.
Jeez, that's not a small thing to say. It just says like nothing.
Yeah.
That's awesome.
So this was my baby.
Dan was giving you the tour today, and he was showing you the GSU 25, which was the box that he designed himself, and watching how that was working on the rate tables, getting calibrated. Really moving to a solid state MEMS platform is so much safer.
So it has to have 3 different, like your inner ear basically? Is it?
Yeah, that's a good way to describe it. It actually has gyroscopes, which are sensitive to rotation rate, and it has accelerometers, which are sensitive to things like gravity and linear acceleration. So the reason why this is the same idea that the inner ear has 3 different. The rate gyros are pretty similar to the 3 canals of your inner ear, which are sensitive to spinning, rotation. And the idea is that the accels and the rate gyros complement each other in a lot of ways. The weaknesses of one complement the other.
Yeah, but it's nice to have, if both of these displays go down, you still have a lot of functionality in the G5.
Yeah, I talk about doing the instrument with the 6-pack, but the truth is I had a G5 and a 430, so really, it's not really a 6-pack. It's kind of cheating.
Wild. Yeah.
Well, don't get me wrong. I'm willing to leave the 6-pack in the dust. I just think
that's an interesting point, though, because the
guys.
reality is that this airplane's not going to be flown by just Steve or myself. It's going to be flown by a number of guys that want to get checked out on it. It's going to be operated by the Canadian Historical Aircraft Association, and some of these guys are not glass panel guys yet.
We're documenting the process of building a Vans aircraft RV-14. We got a lot of amazing footage on this trip that won't make it into this episode, but it will show up in the airplane build vlog, and I'll be sharing a bunch of the raw footage with Patreon supporters.
Now, a lot of people, their concern is, how do I transition from a 6-pack to glass? We can do several different stair steps, and flight schools, training schools are really big on this, to where we can come in here and access my PFD options. I can go ahead and put round gauges on there. I can also turn off my synthetic vision and go to a round gauge attitude presentation. So a lot of home builders, I work with a lot of experimental home builders that are, they're retired, they're older guys, they have never flown anything but a 6-pack before. They said, I just don't know about flying this thing for the first time using all of the altitude and speed tapes and the synthetic vision. And I was like, we can really easily stair step you up on that sense. So we got a common 6-pack here overlaid on the PFD. Then you can go ahead and start moving into the little options here. So I can look at the options. I can go ahead full screen for the attitude presentation. That gives them a little bit more information in the background, so they can start picking apart and getting used to information on the broader scale. When it goes full screen, then I can go ahead and go in there, give them the tapes back, and that's going to give them the presentation of the tapes. So traditional blue over brown type of flight display, because synthetic vision is a lot of information, and so some guys like to just prefer to fly the system just like this. Then I can come back in here and go ahead and give them their synthetic vision back, and that's going to overlay the airports, the traffic, all of that data piece on there to where they can stair step in there.
So the reason why they call this the Human Factors Lab is just because we're working through these workflow things with the system.
Exactly. Yeah, we've done a lot of different evaluations. We put pilots in here. We ask them questions. Find this button. Touch that thing.
Yeah. How long does it take? The Human Factors Lab was amazing, and it's definitely worthy of its own episode.
All right. Go ahead and hit enter there. Perfect. Then you can load that. Don't activate it.
Oh, no.
This is a human factors bug that we are not real.
That is a human factor.
It always happens.
Yeah.
So stay tuned. I didn't want to do this one a disservice by trying to cram it into this episode, which is really about testing. So let's get back to that. That goes for hours sort of thing?
Yeah, he'll be running that, I think, for about 8 hours, and then we'll flip the axis and we'll do the other. You have to do all 3 axes, so that's what I was just kind of saying in terms of that plate. You actually rotate the table down, and then it connects to that slip plate, so you can do the other direction.
God, that's hard on wiring.
That's it, right? So you're trying to see, will something finally break or shake loose?
Yep.
So another thing that we really love about our system is the servos. So we were downstairs in the reliability lab watching them trying to break the servo, see how far we can take it to failure. Being able to sit here and spin the servo is a great experience, and not having that shear pin.
And describe a shear pin for people that don't understand what that is.
My understanding of shear pin anyways is, so you get one shot at it. So you have to be able to overpower the servo the autopilot system if you need to. So the shear pin is designed to literally just shear, break, and your autopilot's done, it's toast, you got to have it repaired or overhauled. So this just doesn't have a shear pin. It's a clutch design that engages, and it mitigates the need for a shear pin, basically. So
solenoid driven, by the way.
Exactly.
Yes.
Right. Yeah. Yep. So that's the big thing with shear pins and existing autopilot kind of tech that we've overcome. Part of the other smarts as well is variable torque. So a lot of servos technology today will just be you get one motor and it just has one torque setting. So it allows us to vary the torque, and the benefit to that is electronic stability protection is a direct result of that. And what that technology is helping keep us in the envelope when we need it. And when we're doing special things, if you're doing acrobatics, you can obviously disengage it because you want to go past that. But What electronic stability protection does is it provides kind of tactile cues when you are just flying VFR, you're looking outside the airplane, and you get too far into a roll in a normal flight, again, not acrobatics or something like this where you're doing maneuvers, it'll let you know. So you'll get some feedback. The servo will give you some feedback to nudge it back to straight and level.
Can I do a kind of a spiral dive scenario?
Sure.
Take a little power out. So now I'm out of control. I'm in IMC. I don't know what I'm doing. I'm well beyond where I should be. Airspeed's good. Altitude's good. It's...
Engaging autopilot.
Oh, very smooth. It really doesn't G-load anything. It's very...
It's G-limited.
Yeah, okay. Okay, beautiful.
And it does not go to heading. It is wings level, 0 vertical speed. Now you must decide what you want. If you want heading, you got to select it.
Okay. That's wonderful. Yeah, that adds a lot of flight safety.
Yeah, so... And the same thing will be true if you wanted to do a manually flown stall. It will also try to push the nose down as you approach stall, kind of like it did on the Autopilot, except it'll do it manually flown as well.
This looks like there's a coating on the servo for kind of conformal, like waterproofing.
Yeah, definitely.
Environmental considerations, yeah.
Because, you know, these are out in the
Board
wings,
design
not always...
is just so elegant. Like, just looking at it, it's just really... That's kind of the stuff that impresses me. Like, I like it.
Yeah. Well, you saw it, we can shake it apart, so we want to make sure it stays together when you're flying.
Yeah. So yeah, we're putting conformal coat on these boards.
Yeah, that adds a ton of robustness and environmental protection, right?
This particular robot over here is building our GSB-15s.
And here's a bunch more of the testing and factory scenes that I just thought were awesome, so I'm just going to kind of montage them together, so enjoy.
So like that plate that's just dropping now, the next one it gets, it sets on that platform there, so its camera can then see it's taking a picture of it real quick and saying, yeah, that's the right part. And if I put the wrong parts there, because we had different sizes of them, it will recognize it's the wrong size. Yeah, because this is a shaker table, so it brings out new ones, but then it's backlit, and if it can't see one separate from others, it'll vibrate it a little bit. And then the camera looks again and says, yep, I can find it now, and then places it in the chute. And then the bagger not only closes the chute, but it prints out the part number, the description, and the date and time stamp of when it was done.
Just do it an hour.
Put it this way, our whole assembly area, robotic and human combined, did 1 million kits last year.
What happens if your airplane gets hit by lightning? Yeah. We figured that out down here.
Yeah.
You can end up with something like this.
Does it still work after that?
I don't know if this one did or not. I didn't do the test, but the main point is that it's still intact and it's still attached to the aircraft.
Right, because it could just blow up.
Yeah. So I've got a test set up here with just a little short wire in here, and I'm going to show you guys that this system can put out like 10,000 amps, and so the wire is actually going to jump.
Holy crap.
So the lightning strike doesn't actually touch the wiring on the inside. It travels through the outside of the aircraft and departs, but that creates a big magnetic field which causes surges like that on the wiring.
So if that wire failed, would it just blow up, or what would happen to it?
So usually the wiring is not the thing that has the problem, it's the equipment the wire is connected to. We certainly have had to test, we've had to vaporize coaxes down here before just to prove that the equipment still survives.
When it comes to the software release, my job is just to find problems and tell somebody else about them so they can fix them. So before anything gets out, we go through and do regression testing. So we've got a big list of things that we go through, and we say every time that we release new software, we have to say everything still works, all the minimum functionality. This isn't my only project that I'm working on. I work on another bigger jet, and I said, hey, no, we're not doing this. We're not pushing it out right now. I need time to sit down and test it. Just leave me alone. Let me play with things. Let me touch stuff, and I get no pushback from management. There's no pressure on me to cut corners. There's it is 100% safety.
What we're aiming to do here is to quickly bring hardware in here and subject it to extreme environments and understand what the data sheet says it's supposed to do and then what it actually can do, and we can then understand margin in terms of the product. It's too cold in there right now.
So you just got a test pattern running to see kind of how the display reacts? Some display lag because of the cold right now?
Yep. We can go to about almost minus 100 degrees C because it's liquid nitrogen sourced. So there's some tanks outside here we can dump liquid nitrogen in and get really, really cold. And then we can get hot, so we can get up to about 200 degrees C. We usually don't go that hot because you will start melting solder when you get that hot. So some of the capability of the equipment's beyond the ability of the product to even survive.
More importantly, I think it's beyond the ability of a human.
Yes. But the whole idea here is many of these environments are well above what a normal pilot would ever experience, particularly if you're in a cockpit.
Right.
But what we're trying to do again is understand margins.
Now, not that you ever have high altitude effects when you're flying, or dry condition effects, but static discharge is a thing.
Yeah.
Right? Typically we test in the 10 kV range. We'll put the product there and we will apply static discharges.
I always like to think about the scenario where it's parked on the ramp in Phoenix, Arizona. It's maybe 130 degrees on the asphalt, and then that airplane is getting up to cruise altitude in the flight levels and it's icing up there. You know, that happened in a matter of 30 minutes, and so we want to make sure that the temperature can change, it doesn't shock cool, and things don't go bad. But really, airplanes are a unique form of travel where you do traverse a wide range of conditions in a very short amount of time.
If you only test to what your local environment is, you never see the effect the way it will happen in the real world. And our objective is to test, to model the customer's real world. We want to know that it works not just in the lab, but where the customer's going to use it.
Dave's going rogue.
Yeah.
Huge thanks to sponsors and Patreon supporters. This was a really big production. There's going to be a lot more of this footage coming in future build vlogs, and I'll be sharing some of the raw stuff with Patreon supporters. But this human factors lab was so awesome, it's definitely worthy of its own entire episode, so stay tuned for that. And until next time, keep your flight chops sharp.
We will break it before you break it, is the goal. And every single
Joey, I'm gonna break it. It's gonna happen.
Challenge accepted.
Yeah.
You didn't want to have kids anyways, right?
No.